Here we are on page 3 of the differential equations packet. We have a couple of examples to work out and just a simple question that we'll address when we get to it. One thing I do want to address before we get to example number 5, if we go back to example number 4 on the previous page, notice because the slope depended only upon what x was and not what y was, notice we had this vertical pattern where everything on this vertical line had the same slope, and that's true throughout the entire problem. And so when you have only an x, you will have this vertical pattern. Likewise, if it's only a y, that is, it wouldn't depend on what x is, then horizontally you would have that same slope going right across your page. So it helps in drawing slope fields. It also helps in identifying slope fields of functions when we're working with them. However, this one here is a little bit different because we have both an x and a y. So there may be a pattern, but it's not going to be quite as nice as the horizontal and vertical. So construct a slope field for the differential equation dy dx equals x plus y. Sketch a graph of the particular solution that passes through the point, and this needs to be the point 1, 2, because we don't have the point 2, 1 on this graph. Then sketch the graph of the particular solution that passes through the point negative 1, negative 1. So let's just jump right into it. We're going to start by creating a table that has x and y, and then x plus y. And we're going to have too many values, so I'm going to need to create a second table with x, y, and x plus y. Now, we can just haphazardly choose any of these 12 points and we can start. I would suggest, though, we start in one area and just follow some sort of pattern. So whether you want to go across or down, I generally go down so that my x coordinates stay the same for those points there. So I have the point negative 1, 2, negative 1, 1, negative 1, 0, negative 1, negative 1. Then we have the point 0, 2, 0, 1, 0, 0, 0, negative 1. And then we have the point 1, 2, 1, 1, 1, 0, and 1, negative 1. Again, I'm just identifying the 12 points that we're dealing with. To get the dy dx now, all I'm going to do is just add those x and y values. So negative 1 plus 2 is 1. Negative 1 plus 1 is 0. We get negative 1, and I get negative 2. I'm just going to quickly add these here and add these here. And you can verify that. We get those. Now, how do we transfer these over to here? Well, again, we're just going to draw a little segment. So I'm going to draw a little segment through the point negative 1, 2 that has a slope of 1. I'm going to draw a point or a little segment through the point negative 1, 1 that has a slope of 0, and so on and so forth. So let's start right here with the point negative 1, 2. That's this one. And I'm going to draw a line that has a slope of 1. So I'm going to use these 2 points here just to get an idea of what a slope of 1 looks like on this graph. And I'm going to go ahead and then just draw this at about the same slope. At negative 1, 1, that's this point, we have a slope of 0. At negative 1, 0, we have a slope of negative 1. So again, that's going to look like this. And then at negative 1, we have a slope of negative 2. So the one thing to keep in mind is this. When it comes to grading slope fields, if you have to draw one, they will check to make sure that slopes of 0 are horizontal, slopes that are undefined are vertical, slopes that are positive increase, the slopes that are negative decrease. They're not going to get really picky to say that that's actually not negative 1, it's negative 1.1 or negative 0.9. All they want to see is that if that's negative 1, they want to make sure that negative 2 is going to be slightly steeper than that. So don't draw it at the same angle or at the same slope. Make my slope of negative 2, if that's negative 1, make my negative 2 just a little bit steeper. Okay, let's go to 0, 2 now. That has a slope of 2. I'm actually going to start at the origin here. I'm going to build my way up. So that has a slope of 0. At 0, 1, we have a slope of 1. And then up here at 0, 2, I have a slope of 2. So again, I'm going to go just a little bit steeper than where I was. Okay, and then a slope of negative 1 down here. Up here, I have a slope of 3, 2, 1, 0. So I'm going to start with 0 and then work my way up. So 0 is here. A slope of 1 is here. A slope of 2 is here, and then a slope of 3 would be here. Now, looking for and identifying patterns here, I see like this little diagonal line, this oblique line, that all has a slope of 0. All of these have a slope of -1. All of these have a slope of 1. So when it comes time to draw my particular solution, anytime I pass through this diagonal line, I want to make sure my curve has a slope of 1. Anytime I pass through this diagonal line here, I want to make sure my curve has a slope of 0. So let's go ahead and draw our particular solution through the point 1, 2. So I'm starting here at 1, 2, and I want to start my curve so that it has a slope of 3. But by the time I pass through this line right here, my slope has to be 2. So as I come down here, I'm going to have a slope of 2 passing through that. Then, as my line continues to come down, when I pass through this line right here, my function should have, or my graph should have a slope of 1. When I pass through this diagonal line, my graph should be flat, have a slope of 0. By the time I pass through this one, I should have a slope of -1. So there we are, slope of -1. And then if we would continue, I would have eventually a slope of -2 as it continued on. But that's a pretty decent graph for a particular solution that passes through the point 1, 2. Now, what about a particular solution that passes through the point -1, -1? Well, that's this point right here. And notice we're going to go right off the page pretty quick because I've got a slope of -2 down here. This is -2. And so eventually it would get up towards this line where I'd have to have a slope of -1. But for right now, this is just going to continue going up this way here. Okay, so it's going to have a little bit of a curve, but it wouldn't have too much of one. Okay, again, that's not the best one, but it's a very tough point to start with. All right. Number 6 and 7. Given a differential equation, how can the correct slope field be selected from multiple choices? And given a slope field, how can we select the correct differential equation? So quite often you'll see on different worksheets in calc books as well as online, they'll give you several different differential equations. They'll give you several slope fields, and we just play a matching game here. So how do we do that? Well, basically the easiest thing is to use some easy slopes. Just like we did up here in example 5. Find when we have a slope of 0. Maybe find out when we have a slope that does not exist or is undefined. Possibly even 1 is a nice easy slope. So just work easy slopes until you get enough of a picture of what's going to be either the differential equation or the slope field that matches. So example 6 gives us 4 differential equations, and we have to match the slope field. So let's start with the first one right here. dy dx equals x minus y. So let's first of all ask, when will dy dx be 0? Well, x minus y is going to equal 0 when x is equal to y. So I need to find a slope field that wherever there is a point where the x and y are the same, such as 1, 1, 4, 4, -2, -2, that point is going to have a little segment through it with a slope of 0, a little horizontal line. So as we look at down here at this first graph, so the point 1, 1 would be around here, the point 2, 2 would be here, the point 3, 3 would be up here. Notice those lines do not have a slope of 0. We don't have any horizontal little segments here. Whereas if I look at B and I start moving up, notice in this area here, I'm getting a slope where the graph is essentially horizontal. So we would have a slope of 0 here, slope of 0 here, slope of 0 here, and here as well. So I'm going to say that that's a candidate. Let's just quickly eliminate C and D. Well, as I scan up here, I do not see a slope of 0 anywhere. This says a slope, almost looks like it's 1. And when I come over to D, I have a slope of 0 around here, but it kind of goes away as we move away. So this first one here would be B. Okay, I think it's a little bit easier when we get to something like number 2, dy dx. This would be 0 when either x is 0 or y is 0. Now, x is 0 is just the y-axis. Every point on the y-axis has an x-coordinate of 0. So what we're saying is on the y-axis, I should see little horizontal lines that have a slope of 0. Well, y equals 0, the derivative would also be 0. So points that have a y coordinate of 0 on the x-axis. So we should therefore see little segments that are horizontal on both the y-axis and the x-axis. So as I look at A, I do see the horizontal lines on the y-axis, but on the x-axis it appears to be vertical at those points. Okay? We're already done with B. As I move to C, we do not have, here it almost looks like we might have horizontal lines on the x-axis, but definitely not on the y-axis. D, we have horizontal lines on the y-axis, and on the x-axis it's hard to see, but we need to look above and below that. Notice the slope is negative above the x-axis, positive below the x-axis. So that means we do pass through 0 at that point, or we could anyway. So the only one that is likely, that is possibly this one, would be D. What about this? Well, here, dy dx is 0 when x is 0, and it's undefined when y is 0. So that means I'm looking for a graph that when x is 0, that's the y-axis, we have horizontal lines. And when y is 0, that's the x-axis, we have vertical lines. And we saw that back here in graph A. Horizontal lines on the y-axis, vertical lines on the x-axis. So this should be A. And the process of elimination would give us that 4 is C, but let's just verify this real quick. Dy dx is going to be 0 when the numerator is 0, that's y, that's the x-axis. And sure enough, it looks like we have horizontal lines on the x-axis. And dy dx is undefined when the denominator is 0, when x is 0, that's the y-axis. And if we scan here, it certainly looks like these slopes are going to be vertical here. So that would be C. And that's page 3.